Now let us look at this function here, f of x equal to x plus 3 times x minus 1. We are going to study the graph of this function, and then we are even going to draw it on a regular graph sheet. Okay, so we'll do one thing at a time. And in the first case, what is the value of a, that is the coefficient of x square for this function? See here, x plus 3 times x minus 1. On multiplication of this x with x, you will only get x square. And how many x square is? Just beside x there is no number. So it is just 1 x square. So the value of a, which is the coefficient of x square, whatever is the numerical factor that is there beside this x square, is called as the coefficient of x square, and in this case it is just 1 x square. Therefore my value of a is equal to 1. A is 1, that's all. Now list the two linear factors of the function, and then what value of x makes each linear factor 0. So what is the first linear factor? It is x plus 3, and the second linear factor is x minus 1. Linear means it is just the degree of x is 1. In your previous classes you studied the standard form of a linear function, that is y is equal to mx plus b. That's the thing, linear equations and all. So here I have x plus 3 is one factor, and the other one is x minus 1. I'm writing it separately so that I can find the zeros also. Okay, these are the two linear factors. Now find the zeros. So in order to find the zero, I'll write x plus 3 is equal to 0. Take away 3 on both sides. So x is equal to negative 3. What happened here? This negative 3 got cancelled. Right? This x equal to negative 3. What value of x makes the linear factor 0? That is, on replacing this x with the negative 3, if I write here x is equal to negative 3 plus 3 gives us 0. Same way here, if this is 0, the whole thing will become 0. 0 times any number gives you 0. That's what it means. Now we have x minus 1. So I'll write x minus 1 is equal to 0. Add 1 to cancel that positive negative 1. We have to add 1 to give x is equal to 1. So this is the second value of x. That's all. That's what you have to find. When x is equal to 1 and x equal to negative 3. Those are the two values of x that makes this 0. Then evaluate both the factored form and the standard form of f of x is equal to x square plus 2x minus 3 for each value you identified in part B, that is over here, these two values, 1 and negative 3. Are these values you expected, and why? That is, what is the answer that is going to be? Do you know what is the answer you will end up with? On substituting these values of x in the function f of x equal to this x square plus 2x minus 3, or in the factored form over here, x plus 3 times x minus 1. Let us see. So we have f of x is equal to x square plus 2x plus 3, that is the standard form, and this is the factor form. Okay, now I'll substitute x is equal to 3. Take x is equal to 3. So f of 3, oh, it's negative 3, sorry, you can just put a negative 3, is equal to negative 3 square square plus 2 times negative 3 minus 3. That is how much? I'll just use calculator. I'll show you how to enter these numbers in the calculator. Alright, I'll turn it on. Okay, quit, second and mode. You can quit, and always make sure that we enter this negative sign in the parentheses. That's most important. And square plus 2 times negative 3, close the parenthesis, and minus 3. Hit enter. So your answer is 0. So this is 0. When x is equal to negative 3, it becomes 0, right? For x value negative 3, the value of y became 0. Similarly, if I take x is equal to 1 and substitute f of 1 is equal to 1 square plus 2 times 1 minus 3, the answer is going to be 0. Just verify. Now in the second part, in the factored form, I am substituting x equal to negative 3 to give f of negative 3 is equal to, that x is negative 3 plus 3 times negative 3, x value is negative 3 minus 1. So what is negative 3 plus positive 3? 1 is the opposite of the other, so 0. You got 0 times negative 3 minus 1 is negative 4. Okay, and the result is 0. Same thing you see. For x is equal to negative 3, the value of y is 0. And substitute 1 for both of them, like f of 1 is equal to 1 plus 3. Now this x is 1. So that x is 1, this x is also 1. 1 plus 3 times 1 minus 1, that is 0. 0 times anything is 0. And you will end up getting 0. So what we have to understand here is, like, as you have already guessed, I think, whenever you substitute these x-intercepts in the function, whether it is in the standard form or in the factored form, the result, the value of the function is going to be 0. Right? That's why we call them as the zeros of these functions. The answer, the result, the value of y is 0 for those x values, whether you take it in the standard form or in the factored form, even in the vertex form. It is just the same answers we'll get. Now, use your zeros and what you have learned about the symmetry of parabolas to determine the axis of symmetry and the vertex. Now, what are the two zeros that we have? Just now we saw x is equal to negative 3 and x is equal to 1, right? That x was negative 3 and other value of x is positive 1. So to find the axis of symmetry, I have to add these two zeros of that function and divide by 2. That is, you are finding the midpoint on the x-axis. Alright, I'll show it to you in the graph in a minute. Let me find axis of symmetry. In short, I'll write AOS, that is axis of symmetry, is equal to negative 3 plus 1 divided by 2. That gives you negative 2 over 2, that is negative 1. So your axis of symmetry, which is the value of x, that is negative 1. Okay, you can check it on your calculator just in case. I'll just say start parenthesis negative 3 plus 1 close the parenthesis, then divide 2. That gives you -1. Okay, now let me show you it in the graphical form. I have here x square, the same function, x square plus 2x minus 3. Alright, hit the graph. It is not very good. I'll try to take some more values for y. And with reference to this x, let me see. When x is -3, y is 0. And again 0 you are seeing right away there. So let us just make it in a standard form and see how it looks like. I will go to zoom and hit 6. So standard form you will get. This is better. Okay. Now here when x is equal to -1, we are seeing that that line is the axis of symmetry. That's what you are saying. So let me go down some more to your axis of symmetry. Right, here we have our axis of symmetry. And I'll take the calculator and enter it here. At this point, x is equal to -1. Right over here. This is the line. Okay, that is your axis of symmetry, which divides the graph. This parabola is divided into 2 equal parts by this line, where x is equal to -1. Okay. Then you are also asked to find the vertex, means the coordinates of this point. When x is equal to -1, what is the value of y? Using this graph, we can guess, or you can go to the table and find what is the value of y. Here in the table, when x is equal to -1, the value of y is -4. So 1, -4 is your vertex. But let us find that vertex using this function and substituting the value of x, that is -1. So we have the function f of x equal to x square plus 2x minus 3. Okay, substitute x is equal to -1. This is the value of that x. Okay, let me substitute f of -1 for that value of x. -1 square plus 2 times -1 minus 3. That gives you how much? That is -1 square is +1 minus 2 minus 3. That gives you -5. And 1 minus -5 is -4. Or just use your calculator. That is how much? -1. Okay, let me clear up everything. -1 close square plus 2 times -1 close minus 3, hit enter, -4. Right? So for x is equal to how much? -1. The value of y is -4. That you have seen through the table function. -1 and -4. From the graph you can see and guess this is 1, 2, 3, 4, -1, 4. Or by substituting this axis of symmetry in the given function, you got the vertex. This is the vertex. Okay. So you have your axis of symmetry and you have your vertex. How did you find axis of symmetry? Add the zeros and divide by 2. And how do you get the next coordinate? Just substitute. Okay. Then you have use the zeros and the vertex to draw an accurate graph of the function. See, it's just first I'll show you the rough sketch. Like we have, this is your x-axis, that's the y-axis, and the vertex is at -1, -4, and the graph we have already seen is going to be like this, right? Just a rough diagram, I'm showing it here. Now, to plot it on your regular graph sheet, you need the values for x and y. Okay. Now, what are the suitable x and y values that I have to consider? I will take in my center, this is the point, that is the vertex is the main point here, that is the turning point. So that vertex is the turning point where the graph turns around like this. So that vertex, which is -1, -4, I'll put it in the middle. 1, 2, 3. So I'll write here -1, and the y coordinate is -4. And above you go down by 1. So before -1 it was -2. Then take away one more, that gives you -3, and then -4. And when you go higher up, -1 plus 1 is 0, 0 plus 1 is 1, and even 2 you can write one more value. And what are the y values for this? Corresponding y values, we are all familiar with the calculator, so make sure that we have the right function. Okay, let me hit. We have the right thing here. Y is equal to x square plus 2x minus 3. I typed in a while ago. Just hit second and table. I have to get those values from -4. So when x is -4, y value is 5, then 0, -3, and then -4. So 5, 0, -3. Have here 5, 0, -3, then -4. Afterwards, this -3, 0. It just repeats, right? Because of this turning around. For 0, it is going to be -3, then it will be 0, and for 2, it is that 5. And calibrate your x-axis and the y-axis and draw a neat graph. You can draw the graph on the regular graph sheet, right? So the advantage of knowing the vertex is this. I can have my middlemost points, the coordinates, as the vertex, and also I'll make sure that, of course, these x-intercepts are also taken into consideration. That's all. It's very simple. Okay. Thank you. Please try the other problem.